In today's episode, we are going to tackle the parallelogram approach of force resolution. In the previous episode, we talked about resolution using components, and in this example, we are going to use the parallelogram approach. Let's look at the example. A stake is being pulled out of the ground by means of two ropes as shown. This is the diagram. Knowing that A or alpha is 30 degrees and force P is 101.4 Newton. This P is 101.4 Newtons. Determine the resultant of the forces using the parallelogram approach. In some question, the question will be determine the resultant of the forces, just like that. But in this example, you are being restricted to use the parallelogram approach, and this is how it works. So let's look at parallelogram. This figure represents a parallelogram, and we know that with a parallelogram, opposite sides are what? They are equal. The length, this and that, they are what? Equal. So I have this parallelogram ABCD, and one of the properties of a parallelogram is that opposite angles are also what? Equal. So if here is A, here is what? A. If this side is B, the opposite side is also what? B. But they all sum up to 360. And inside a parallelogram, you can have the diagonal, the line that divides the plane figure into two equal parts. So this is the diagonal of the parallelogram. And you can see that this diagonal now divides the parallelogram into what? Triangle. So we can have two triangles in one parallelogram. This is one and this side is what? Two. That's why I'm showing it here. Triangle ACD. So ACD. This second side represents a triangle. And we also have the second triangle as triangle ABC. So this side, the first side, which is ABC, with the diagonal forms one other triangle. Are we okay? So we have two triangles in this parallelogram or in any drawn parallelogram. So let's make the analysis. We are taking one side of the triangle. If I take each side of the triangle, the diagonal will now be part of what? The side. Because this diagonal is forming one side of the first one. This diagonal is also forming one side of the second one. So let's assume this is the first side, which is the ABC side. This is the diagonal. So we have this triangle. This is this triangle. And the parallelogram law of vector resolution was stating that if two forces now represent the adjacent side of what? A parallelogram, the resultant is the diagonal. Remember that the resultant is the diagonal. So when you find the length or the magnitude of the diagonal, you are now going to find the resultant of the two forces. And bear in mind, the parallelogram approach only affects what? Two forces. If there are three, you combine them 2, then you solve it. So this is triangle ABC, and it will represent two sides of what? You have two forces B and C with respect to what? The diagonal. So if now A is representing the diagonal in the first case, here A is the diagonal of the triangle or the diagonal of the parallelogram, we want to find. We will now use the cosine rule for triangles. Remember, if you have all the sides of a triangle given with one angle, we have what we call the cosine rule, which can help you find the other side. Or when you have two sides of a triangle given and the corresponding angle between the sides, you can use the cosine rule to find the other side. That's what we are going to use in the parallelogram approach. So I have my triangle, the first one. I have the side B, side C, and side A. These are the angles, angle A, angle C, and angle B. So I want to find the diagonal, which is A. And now these are forces. I have my force B. I have my force C. This is the formula relating them. Now, the A, which is now the diagonal to represent the resultant force, will now be B squared plus the C squared minus 2 times BC, the product of B and C, cos the angle between them, which is angle A. So I'm finding side A, and it is equal to A squared is equal to B squared C squared minus 2 times BC cos the angle between them. So in the second case, if B represents the diagonal, if now B is the diagonal and I want to find B, it will be the same rule. So this is angle what? B. It will be B square equal to the other side, A square plus C square minus 2AC cos B, cos the angle between them. If I want to find C, which is the resultant here, then it will be C square equal to A square, B square, and the angle what? C between them. So it's quite simple. Now let's go to the problem. This is our problem figure, and I've transferred it here. So this is my forces, the 120 force here. This is P, which is 101.4 newtons here. And I have my angle 25 and A. Remember, A is giving us 30 degrees. So 25 plus 30 will now be what? 55. And because a parallelogram can be drawn from these forces, I'll now draw it into what? A parallelogram. So I now converted this into a parallelogram. Are we good? So the angle, we saw that opposite angles are equal. So 25 plus 30 will be 55. So this is equal to that. And we have the angle given. This is my resultant. This dotted line is my resultant, R, which represents what? The resultant of the two forces. And it is the same time the diagonal of the figure. Remember, the parallelogram law states that the diagonal is now the what? The resultant. So we can choose each side of the parallelogram as our triangle and consider using the cosine rule. Are we good? So, which side should we take? And what are the angles left? Let's find all the angles. So I now have this plus that, 55 plus the other 55 of the angles will give me 100 and what? 10. So when you subtract 110 from 360, you are going to get 250. And when you divide it by 2, you're going to have 125. So this side will be 125. This side will be 125. Remember P, this line P is the same thing here because for a parallelogram, the sides are equal. So this and this are equal. This is equal to that. And this is also 120 here. So I'll take one side of it. So let's assume I take this side. I'm going to have something like this. This is the resultant. This is my side, which represents the 120 side. And I'll close it with the P side, which is 101.4. I'm just taking one side of the what? The triangle. And I have my angle here, which is what? 125. 125. And this is the resultant. So I can now use the cosine rule to find the resultant from this. You can choose any side and it will work. So I can see this is my axis and this is my vertical what? Axis. So if I want to use the cosine rule, then I have two sides and an angle between them I can find. Then my R square will now be equal to 120 square plus P, which is 101.4 squared, minus 2 times 120 times what? 101.4 cos, what's the angle between them? 125. And I'll get my resultant. So my resultant will be the square root. So finally, R will be 196.57 newtons, which is interesting. The idea here is to get the understanding of how to draw your shape and get the answer. Now I know the magnitude of the resultant to be 196.57 newtons. Then what angle does it make with the x-axis? So if I want to get the angle, what do I do? Now I can find the angle the resultant makes with this force. Yes, I can find the angle the resultant makes with this force. So if I want to find this small force, which is theta 1, I can also use the sine rule to do that. So R will be R on sine the opposite angle 125 should be equal to, I have 120 on sine theta 1. So I can manipulate this to get what? My sine theta 1. And I will get this theta 1. Remember, if you get this theta 1, you now have an angle. What is the angle between? So let's look at our diagram. This is my x-axis. If here is 30, what's the angle here? The angle here is what? 60, because it makes an angle of 90 with that. And here is 30, here is 60. So I already have my 60 from this force P. This force P to the x-axis is already what? 60 degrees there. So if I find any angle between the resultant and this force, I will add it to the 60 to get the total angle. So the total angle will now be this theta 1 you got plus 60 will give you whatever you are looking for. And I know my R to be 196.57 on sine 125 equal to 120 sine theta 1. And finally, my angle theta between the resultant and the x-axis theta will be equal to what? 89.99, approximately 90 degrees. So what it means is that with this forces, the resultant is what? 90 degrees, almost. So this resultant of what? 196 will lie on the vertical axis like this. Will be a vertical one. So I can draw it this way and we can have it that with the resultant giving 90 degrees. It's quite simple. Let's look at the second example. Example 2. So two coplanar forces with magnitude 96 newtons and 80 newtons act at a point O. Determine the magnitude and direction of the resultant if the angle between them is 120. So this one is also simple. We can do it here. So we have this diagram as two forces. I always say the parallelogram approach is used to solve for the resultant of two forces. So I can have my axis given like this as the x-axis. I can have my vertical. We solve this example using what? The resolution into component approach. So we have to get the same answer. I have my axis and we have to convert this into what? A parallelogram. So I will trace this force here down this way. So this is the side 96 and I have my 80, then I'll close it with what? The 80. So this is the 80 newtons. Now the resultant will now divide it into what? 2. This is the resultant, R. And if here is 120, the other opposite side will be what? 120. So what will be the remaining? Yes, the remaining angle left. So this will be what? 120 plus what? 120 times 2, so which will be 240. So this 2 is giving us what? 240. When you subtract 240 from what? 360, you're going to get another 120. And when you divide it by 2 for this 2, which will be what? 60 and what? 60. So I'll take any side of what? The triangle. So this is the first triangle, this is the second, with respect to what? The resultant. So I'm taking this side, the first one. So I'm getting something like this. So this is the resultant, and I'm having the 96 force and the 80 Newton force, like this. This is 80. This is the diagonal at the same time, the resultant. This is angle 60. So we can see this is the axis. This axis. So this is the resultant. So now we can use the cosine rule because we have a triangle where we have two sides given with an angle between them and another side which we are looking for. So we can say that our r square is equal to 96 square plus the 80, 2 times 80 and 96 times cos the angle between them 60, cos 60. And with this, my r will now be equal to what? 89.08 newtons. So simple. And what's the angle between the resultant and the x-axis? So looking at this, we brought this triangle here, the same thing. So this resultant makes an angle directly with what? The x-axis. Since this force, the 80 Newton force, is also on the x-axis. Remember the first example we solved, the force wasn't lying on the x-axis, but this one, the force is lying on the x-axis, so we can find the angle directly, the angle it makes with the x-axis. So with this, we can also use the sine rule to solve. So we can say that for the angle, r is opposite to what? Sine 60, which is equal to, we also have a 96 here, is opposite to the theta we are looking for, sine theta, which is the same here. We know our r to be 89.08 sine 60. We have our 96 on sine theta, and we saw that theta will now be equal to 68.9 degrees. So the resultant of this forces makes an angle of what? 68.9 degrees with the x-axis, and the magnitude of r is 89.08. It's quite simple. So anytime you're given any form of a parallelogram, you first have to draw the diagonal to divide it into two triangles, and this is the diagonal representing the resultant of the two given forces, A and B. This side will also be A and what? B. So each side is now a triangle, and when you take the side, this is AB, the resultant, you just go by the formula. We have it theta, the angles it makes. So the resultant square will now be a square plus b square minus 2ab cos theta, and you are good to go. Thank you for watching this episode. Let's learn other subtopics in the next episode. Thank you.